Okay, so for this video, we will be discussing the fourth property of Laplace transform, so which is the change of scale property. So the change of scale property is we have the theorem: if the Laplace transform of f of t is equal to f of s, then the Laplace transform of f of at is equal to 1 over a f of s over a. Okay, so this means that if we have a factor of a, okay, so this is a scale, okay, a scale of t, then it will correspond to a change in the Laplace transform of a factor of 1 over a, and then all of the s over a will be, all of the s, okay, in the original Laplace transform will be replaced with s over a. Okay, so that's it. Okay, so if we have a scale of a, okay, that was multiplied to t, then all we need to do is multiply the Laplace transform with 1 over a and then change s with s over a. Okay, so say for example, so we have, if the Laplace transform of f of t is equal to s squared minus s plus 1 all over 2s plus 1 squared times s minus 1. So find the Laplace transform of f of 2t. Okay, so here we have a change of scale of 2. Okay, from f of t it became f of 2t. Okay, so our a here is equal to 2. So since this is f of s, okay, so therefore the Laplace transform of f of 2t, okay, so is equal to, so following this, so multiplier of 1 over a, so 1 over 2 multiplied by, so all of the s here will be replaced with s over a, or s over 2. So this will become s over 2 squared minus s over 2, okay, plus 1 over 2 times s will become s over 2 plus 1, then squared, and then multiplied with s will become s over 2 and then minus 1. Okay, so from there we simplify it in such a way that the numerator and the denominator do not contain fractions. So this will become 1/2 times, so this will become s squared over 4 minus s over 2 plus 1. The denominator will become, so this will be cancelled, so s plus 1 squared, and then multiplied by, combining this, so this will become, least common denominator is 2. 2 divided by 2 times s is equal to s. 2 divided by 1 times 1, so that is minus 2. Okay, so as you can see, we can already factor out 2 in. Okay, so simplifying this, so as you can see, we can already cancel out 2. Okay, so 2 there and the 2 here. And then in the numerator, we can factor out 1/4. So this will become 1/4 times, so s squared over 4 divided by 1/4, that is s squared. S over 2 divided by 1/4, that becomes minus 2s. 1 divided by 1/4, that becomes 4 over s plus 1 squared times s minus 2. Oops, sorry. So therefore, the Laplace transform, we can simplify the Laplace transform of f of 2t is equal to 1/4 times s squared minus 2s plus 4 over s plus 1 squared times s minus 2. Okay, or you can combine them. So 4 times s plus 1 squared times s minus 2 over s squared minus 2s plus 4. Okay, so that's it. So all you need to do is apply your algebra skills in simplifying. Okay, so for our second example, so given that the Laplace transform of sine of t over t is equal to arctan of 1 over s, so find the Laplace transform of sine 2t over t. Okay, so here our f of t is obviously sine t over t. So our f of t is equal to sine t over t. Okay, so if we have f of 2t, then we will replace all the t with 2t, so it will become sine of 2t over 2t, right? So however, what we are looking for is only the Laplace transform of sine 2t over t. Okay, and our f of 2t has a denominator of 2t. Okay, so therefore, to solve for the Laplace transform of sine 2t, so the Laplace transform of sine 2t over t is equal to the Laplace transform of sine 2t over 2t, okay, times 2. Okay, so because as you can see, when we multiply it by 2, then the 2 will cancel out, okay, in the denominator, okay, which will leave us with sine 2t over t only. Okay, and since we know the Laplace transform of sine t over t, then all we need to do is apply the change of scale property to get the Laplace transform of sine 2t over 2t. Okay, so therefore this will become 2 times, so the Laplace transform of sine 2t over 2t is applying the change of scale property, so we have 1 over a, so our a is equal to 2 times arctan of, so replace s with s over a, so 1 over s over 2. Okay, so if we simplify this, so 2 and 1/2 will be cancelled out, so then what will remain is the Laplace transform of sine 2t over t is equal to arctan of 2 over s. Okay, so that's it. Okay, so what we did here is we apply the change of scale property of sine 2t over 2t, because our given was sine t over t and its Laplace transform is this, so therefore we just applied it here. Okay, so again the 2 there is so that we can get the Laplace transform of sine 2t over t only. Okay, because this, okay, so this part here, this is the Laplace transform of sine 2t over 2t. Okay, and what we need is a denominator of t only, so that's why we multiplied 2 in here to cancel out that 2. Okay, so in that way, so we will what will remain is sine 2t over t. Okay, so that's it for this property. So we will be continuing with other properties on other videos.